Hello and welcome back to another AP3 video, and in today's video we'll be going over SAT math problems, more specifically linear inequalities and one or two variables algebra. We're going to be going over medium, easy, and hard questions today. Valentina brought two containers of beads. In the first container, 30% of the beads are red, and in the second container, 70% of the beads are red. Together, the containers have at least 400 red beads. Which inequality shows a relationship where x is the total number of beads in the first container and y is the total number of beads in the second container? Okay, so they're giving me a lot of information. They're giving me that in the first container, 30% of them are red, and in the second container, 70% of them are red as well. So in 30% in the first container, 70% in the second container. What I'm also given is that there's a total of at least 400 red beads in both containers combined. They also give me that x represents the total number of containers in the x represents the total amount of beads in the first container, and then y represents the total number of beads in the second container. Okay, so for first container, I'm given that there's 0.3 are red. I'm just changing the percentages as decimals. And in the second container, I'm given that there's 0.70 are red. And I'm given that there's at least a number of 400. So what does that mean? Whenever it says at least, that means there's the minimum value of 400 and more. So in one of these inequalities, we gotta look for a number that shows that it's either equal to or greater than 400, and x is the number of beads that's red in the first container, so x would be with the first container, and then y is the total number of beads in the second container, so it'd be y over here, and the y value for the second container. So we can rewrite it as 0.3x. So let me take out the red. So we can rewrite it first as 0.3x for the first container that are red, and then for the second one, I can rewrite it as 0.7y for the amount of beads in the second container, and both of them combined should be at least 400 beads. So in total, I would get 0.3x plus 0.7y is greater or equal to 400, and the answer would be A. And if it said it was no more than 400, it would be the opposite, because combining both containers, if it said it was no more than, it should be less or at equal to 400. But because it says both containers contain at least 400 beads, it's either equal to 400 or more than 400. And all I did was combine the x and y values to what was the first and the second container. Let's do a different question now. A baker sells trays of cookies. Each tray contains at least 50 but no more than 60. Which of the following could be the total number of cookies on 4 trays of cookies? So they're telling me that for each tray, so for one tray, there's at least 50 but no more than 60. So let me write that. So for one tray of cookies over here, so there's the minimum of 50, but there's at least 50, so I'm gonna write x in the middle, but there's no more than 60. So x has to be a number that's between 50 and 60. But they're telling me which one could be the total number of cookies in 4 trays. So for 4 trays of cookies, notice how it says 1 tray for the beginning. So what I have to do is multiply 50 and 60 by 4 to represent that instead of 1 tray, there's 4 trays that contain 50 as the least number of cookies, but no more than 60 in 1 tray, and then combine all trays together. So basically, there's 4 trays, and each tray has at least 50 but no more than 60 cookies in 1 tray. If I multiply that by 4, all 4 containers combine. So if I multiply 50 by 4, I get 200, which is greater or equal to, again, any number of x, because x stays the same, so x, and then greater or equal to 240. So when there's 4 trays, the total amount of cookies is at least 200 but no more than 240. All I did was multiply 50 and 60 by 4 because there's 4 trays, not 1 tray. If it was 1 tray, there's 50 through 60. But because I have 4 trays, that in 1 tray there's 50 and 60, and I combine all 4 to get that there's at least 200 and there's at most 240. So let's go over the answers that's given. A is 165, but it has to be at least 200, so A cancels out. C is over 240, That cancels out. And 285 is over 240, so that cancels out. That leaves us with B because it's greater than 200, but is less than 240. Okay, let's do a different question. Tom scored 85, 78, and 98 on his first 3 exams in history class. Solving which inequality gives the score G on Tom's exam that will result in a mean score on all 4 exams of at least 90. So they're giving me 4 scores, 85, 78, 98, and G, because G is on Tom's fourth exam. So G is one of the exams. And we're looking for what would be the mean, or what we're looking for, what would result in a mean on all 4 exams of at least 90. So notice the word mean. What mean is average. So mean is average. And how do you get the average? Well, you get the average by adding up the total sum. So the total sum of all values, and then dividing it by the number of values used. So for example, I have the values of 85, 78, 98, and G. How many values do I have? 4. But the total number is 85 plus 78 plus 98 plus G. So the mean will look like this. So I have 85 plus 78 plus 98 plus G. How many numbers are there? Well, as I can see, there's 4. So I'd get 85 plus 78 plus 98 plus G, and divided by 4 because the total sum of the values is adding them up together, and number of values is the number of numbers that are used, which is 4. And they're telling us that the score of all 4 exams is at least 90. So they have to be greater or equal to 90. So the scores have to be greater or equal to 90, and it's expressed in equality that looks like this. Because if we write it on reverse, then that means that the mean is less or equal to 90. But no, we're looking for when it's greater or equal to 90, and the only answer that gives us that is C. Okay, let's do medium questions now. The point x53 is a solution to the system of inequalities in the x and y plane. Which of the following could be the value of x? Okay, so I'm given a point x53, and I'm given two inequalities. I'm given y is greater than 14, and 4x plus y is less than 18. So I'm going to rewrite that over here. So y is greater than 14, and 4x plus y is less than 18. And I'm looking for which of the value of x is in the point x53. So what I'm going to do is I realize that I'm given points, obviously, x53, and I'm going to plug it into both inequalities. So the y's are transformed to be 53. And obviously in the first equation, 53 is greater than 14. So that makes that inequality true. Then if I plug it into the second equation, I get 4x plus 53 is less than 18. So now what I have to do is start plugging in numbers and figuring out which one will lead to 4x plus 53 be less than 18. So the thing is that if I use C and D, they're both positive numbers. And if I multiply 5 and 9 to x, I'm going to get a number that's positive, and then that's greater than 18. So both C and D are incorrect because we need a negative number. So let me do B. If I plug in -5, I get 4 multiplied by -5 plus 53, which is less than 18. -5 multiplied by +4, I get -20 plus 53, which is less than 18. And that means I get 33 is less than 18, but that's obviously not true because 33 is greater than 18. Therefore, my answer is A. But let me solve it algebraically like I just did to figure out that makes the statement true. So if I multiply 4 by -9 and then plus 53, and it's less than 18, if I multiply -9 and 4, I get -36 plus 53, which is less than 18. And if I do 53 minus 36, I would get 17. Oops. So that would equal 1 and then 13. I'm going to get 17. And I'm going to get 17 is less than 18. And obviously 18 is greater than 17. Therefore, my answer is A. And you can plug it into Desmos. And if you plug it into Desmos, you'll see that A, negative 953, is a solution to both inequalities. And therefore, that's why A is our X value. Okay, let's do a different question. A moving truck can tow a trailer if the combined weight of the trailer and the boxes it contains is no more than 4,600 pounds. What is the maximum number of boxes this truck can tow in a trailer with a weight of 500 pounds if the box weighs 120 pounds? Okay, so they gave me that the combined weight of the trailer and the boxes it contains is no more than 4,600. So the trailer plus the boxes inside the trailer cannot be any more than 4,600. It can be less, but it can't be any greater. And they're asking me for the maximum number of boxes that the truck can tow. And the truck itself weighs 500 pounds, and each box weighs 120 pounds. So I understand that 4,600 pounds has to be the maximum number. So whatever 500 plus every box equals to cannot be any more. It could be equal, but it can't be no more than 4,600. So I'm left with 500 pounds plus the weight of every box. They tell me that every box weighs 120 pounds. So I can make 120x because we don't know how many boxes are in the trailer that can be in a maximum. We don't know the maximum value of it. So what we can do is subtract 500 on both sides, and I'm left off with 120x, which is greater or equal to 4,100. So now I'm left off with this inequality, and I got it because I understand that the boxes in the trailer cannot be no more than 4,600. The trailer itself weighs 500, and each box weighs 120 pounds. So I write 120x to show that x is the maximum number of boxes that can be used for the trailer, or how much the trailer can hold with the weight of itself. I hope that makes sense. So now what I have to do is figure out any number of x that can be used, and when we plug it into the equation, I get a number that is less than 4,100, but that is less than 4,100, or that is equal to 4,100. And I hope that makes sense. So now what we have to do is honestly use a calculator, because doing this mental math or doing this mentally can be kind of hard if you don't know how to solve it fast, because in the SAT there's a lot of problems where you can use a calculator, and this is one of them in my opinion, because solving it normally is going to be a little bit tricky, but if you use Desmos or a calculator that's given, you'll solve it quicker. So if I do 34, if I say there's 34 boxes, each of them weighs 120, I get 4,080. So 120 times 34, that gives me 4,080, and we can see that number is less or equal to 4,100. So A can be one of our answers, but let's make sure B through D are not one of my answers either. If I make it 35 boxes, I'm gonna get the weight of 4,200, which is less or equal to 4,100. And as we can see, when we plug in 35, it's greater than 4,100. Therefore, B, C, and D are incorrect, and the only answer it can be is A. Because A, when we have 34 boxes, it is less than 4,100. Okay, let's do this question now. The shaded region shown represents the solutions to which inequality? Okay, before I do anything, I look at every single inequality and see what's different. I see the signs are different. I see that every single one of them have the same y-intercept or 1, and I can see that the slopes are different as well, the x's. But I realized that if I look in the graph has a negative slope, because as x is increasing, the y values are decreasing. Therefore, the slope is negative. So I erase A, and I can erase C, because if we look at the graph, the line is decreasing. As x increases, y decreases. The only way that the slope can be positive is that if x increases, y increases. But because y decreases when x increases, therefore A and C are not solutions. And let's look at the shaded region. Let's say I plug in 4, and 4 obviously equals 0 when x equals 0. However, when I look at 5, let's plug in y equals 5 on both. Right here, let's plug in y equals 5 on both inequalities to make sure that the statement is true. So if I plug in y for b, I get b is less than 1 minus 0, because the x when we have the y-intercept, x equals 0, and 0 multiplied by -4, that just gives us 0. So we get 5 is less than 1, and therefore that cannot be our answer. So our answer is D. But let's plug in 5 to make sure that the statement is true. If I make y equals 5 on D, I get y is greater than 1 minus 0, because again, we're looking at the y-intercept. So x is 0. So again, -4 multiplied by 0. Anytime we have a number that's multiplying by 0, it always equals 0. Therefore, I'm left with 5 is greater than 1. So I get 5 is greater than 1, and that is true. So the answer is D. Okay, now we're going to do hard questions. A number x is at most 2 less than the value of y. If the value of y is -4, what is the greatest possible value of x? So what I like to do first is use the first information given. We're given that x is at most 2 less than 3 times the value of y. So what it means by at most is when x is less than or equal to the value of 2 less than 3 times the value of y. So x is either equal or less than the value of y multiplied by 3 minus 2. And we can rewrite that in an equality as 3 multiplied by y minus 2, because we're given that it's 2 less. So 2 is subtracting the value of 3 multiplied by y. And then we're given that the value of y is 4. So we can rewrite that as y equals -4. And they're asking us for the greatest value of x. So what it means by greatest is when x is equal to the value that is greater or less than x. So what we would like to do is plug in -4 into the inequality and solve for the greatest value of x. So we can write that as x, oops, it's in highlighter. We can rewrite that as x is less or equal to 3 multiplied by -4 minus 2, and then 3 multiplied by -4 equals -12 minus 2, and we can rewrite the inequality as x is less or equal to -14, and the greatest value of x is -14 because x can be less or equal to the value on the right side, and the right side has the greatest value, -14. Therefore, our greatest value of x is -14. Okay, let's do another hard question. A business owner plans to purchase the same model of chair for each of the 81 employees. The total budget to spend on these chairs is $14,000, which includes a 7% sales tax. Which of the following is closest to the maximum possible value of price per chair before sales tax the business owner could pay based on the budget? Okay, so we're given a lot of information. So we're given that the business owner wants to buy the same model of chair for 81 employees. So 81 people will be getting a chair. And we're also given that the budget is $14,000. So we can write the inequality already as 14,000 is the greatest number that we can use, because the budget is $14,000 and we can spend anything because it's the budget. The budget means that it's the number that's given or less. And because 14,000 is our budget, it cannot be anything greater than 14,000, but it could be equal or less than 14,000. But it also includes a 7% sales tax. So what does that mean? That means that when we look for the price of the chair, P, and then multiply that by 81 employees, because 81 employees will be getting the same model chair or the same price per chair, and then we multiply that with the sales tax because it's included in the budget. So we can write the left side of the inequality as there's 81 employees, and 81 employees will get the price per chair. So 81p will be getting 1 chair, and then it also includes a sales tax of 1.07 of 7%. Sorry, so you can write that as 1.07. So now what I have to do is divide the sales tax, so we get So we can look for the maximum possible value per chair before sales tax. So if I do 14,000 divided by, so 14,000 divided by 1.07 sales tax, I'm gonna get a huge number. So let me do this really quickly. I'm gonna get a number of 13,084 if we round it up. So I'm gonna get 81p is less than or equal to 13,084. So this is the number of value before tax. So I took away the tax, and this is the inequality to look for the maximum possible value of chairs before the tax sales. So now what I have to do is solve the price per chair, so we can know how many chairs that we can buy for 81 employees. So 81 employees will get one chair, but we have to look for the maximum price of a chair per employee. So if I divide 13,084 by 81, I'm gonna get a number of, so if I divide 81 on both sides, I'm gonna get p is less than or equal to, if we round it up, we'll get 161.53. So the price per chair can be equal to or less than 161.53. Therefore C and D are incorrect because they're greater than the maximum possible value per chair. It can be A because it fits in an inequality. However, they're asking us for what? The maximum possible value, and therefore our answer is B. And I'm able to do that because it's the maximum possible value per chair. Okay, let's do the last problem for today. A laundry service is buying detergent and fabric softener from its supplier. The supplier will deliver no more than 300 pounds in a shipment. Each container of detergent weighs 7.35 pounds, and each container of fabric softener weighs 6.2 pounds. The service wants to buy at least twice as many containers of detergent as containers of fabric softener. Let's D represent the number of containers of detergent, and let S represents the number of containers of fabric softener, where D and S are non-negative integers. Which of the following systems of inequalities best represents the situation? Okay, so we're given a lot of information, so let's digest everything right now. So obviously I'm given that the delivery will be no more than 330 pounds. So that is the max number, like we've been going over this whole video. We're also given that each detergent weighs 7.35 pounds and each fabric softener weighs 6.2 pounds. I'm also given, which is the most important information, that the service wants to buy twice as many containers of detergent as containers of fabric softener, and D represents detergent and S represents fabric softener. So if D is detergent and each weighs 7.5, I can write 7.35 detergent, because each detergent will weigh 7.35. So if we only have one detergent, or D1 equals 1, I might get 7.5. So I add that with 6.2 pounds of softener, because the same rule applies. If I have one fabric softener, that weighs 6.2, because he told me that each container weighs 6.2. So if I have S or two fabric softeners, each of them will weigh 6.2. I hope you see the pattern that I'm going with. And they tell me that it can be no more than 330. So both the detergent and the fabric softener has to be less or equal to 300 pounds. And as we can see, all answers have that equation or inequality that I wrote. So we can't cross anything out. However, look what I highlighted in blue. Like I said, it was important. The service wants to buy at least twice as many containers of detergent as containers of fabric softener. What does that mean? Basically, they want double the amount of detergent as they use for softener. So if, for example, I have two fabric softeners, I want twice the amount of it with detergent. So I have 4 detergents per 2 softeners, fabric softeners, because they want twice as many detergent as fabric softeners. So we can rewrite that as D is greater or equal to S, because like I said, detergent has to be twice, or if not more, than the value of fabric softener. Therefore, the only answer it could be is C. It can't be, actually, the answer is A. A because 7.35 corresponds to the fabric detergent. It can't be C because they multiplied 7.35 for no reason. Therefore, the only answer is A, because it shows an inequality, and it also shows that detergent is greater than twice the amount of fabric softener. This is the end of the video. Thanks for watching.